students watching. Good. Let's score our review questions. Number 2 of chapter 15 review. Distinguish between the Arrhenius and Bronsted-Lowry definitions of acids and bases, which includes, or do that, and then second question, which includes a wider range of substances. Right.
The Arrhenius definition is a substance that produces hydrogen ions when dissolved in water, while the Bronsted-Lowry definition is a substance that can donate a proton to another substance, which doesn't have to be water, any substance. And do you want the second question as well? The Bronsted-Lowry has a wider range of substances.
Okay. So what was your Arrhenius definition?
A substance that produces hydrogen ions when dissolved in water.
Is an
Acid.
and what about a base?
A base, check, is a substance that produces hydroxide ions when dissolved in water.
Yes. So that's what you should have for the Arrhenius. An acid produces a hydrogen ion, and a base is a substance that produces a hydroxide ion when it's dissolved in water. And the Bronsted-Lowry is as follows. Hopefully that's what you guys have. And the Bronsted-Lowry can be used of a wider range of substances. And Arrhenius is only narrowed to aqueous solutions. Just remember that. And remember how to spell Arrhenius. So the 2 R's. R. Arg. Arrhenius. RH letter blend combination. Okay. Number 6. Question number 6. What term refers to a reaction between an acid and a base to form a salt and water? Logan.
Neutralization.
Neutralization. So, whenever you hear the word neutralization, it means when an acid and a base react to form a salt and water. The acid and the base are neutralizing each other, which makes a salt, and then also water. Because a salt is any ion that has a cation that's not hydrogen and an anion that's not hydroxide. Because it makes a salt and water, so it can't have water to add ions in it. So that's neutralization. Neutralization is not when you gradually add an acid or a base into a solution to neutralize it. That's not neutralization. What is that called? When you gradually add an acid or a base into a solution to neutralize it. Titration. Yeah. That's used for like figuring out the concentration of something. So, but that's not those are 2 different things. Neutralization and titration. Those are 2 different things. Number 10. How does the normality of an acid solution relate to the equivalent mass of the acid?
Normality is the concentration of a solution expressed as number of equivalents per liter of solution.
Did you ever?
Basically.
Basically. Yep. Could have basically written out that equation for normality. Normality equals the equivalence per liters of solutions. Or written that solution containing 1 equivalent mass of an acid will be 1 normality of the same solution. So 1 equivalent, 1 acid, 1 normality. So they're related. Number 11, in your own words, explain why a 1 molarity solution of hydrogen chloride or hydrochloric acid and a 1 normality solution of hydrochloric acid may have, or those two have the same concentration, but a 1 molarity hydrochloric acid solution and a 1 normality sulfuric solution. That solution does not. So why did the first set of solutions have the same concentration, but the second set didn't?
I have the first two solutions have equal equivalents per mole, or equivalents to mole, while the last two solutions have different equivalents.
Yeah. What is the second one? What's the relation between the second one? So the first two are the same.
They
How
have
are
the
the second? How's the second one different?
with the amount of hydrogen that it had, like the amount to give away. The first one is 1, the second one is 2.
So the first one, the first set, both of them were monoprotic. Know what that means? Both of them had 1 hydrogen they could donate. That means they're both monoprotic. They can both donate 1 proton, which is 1 hydrogen. They can both donate 1 hydrogen, so they're equal.
This doesn't make any sense.
Yes, it does.
What do you have?
Because N equals M.
That's the first one. The first one, that explains why the first one has the same. They have the same concentration. They both are monoprotic, so they equal. They can both donate 1. So 1, 1. They're equal. The second one, the 1 molarity of hydrochloric acid, which is, it's monoprotic because it can donate 1. HCl, it can donate 1 hydrogen. It's monoprotic. Second one was sulfuric acid, which is H2SO4. It can donate 2 hydrogens. So it's diprotic. So while the first one, they're both monoprotic, they're both equal. The second one, we have a monoprotic and a diprotic, which means we're going to need 2 times of this to neutralize that. So we're going to need 2 times the molarity to neutralize or have the same concentration, which means we're going to have this. So they're not going to be the same.
Is my answer okay? I just have HCl is monoprotic and H2SO4 is diprotic.
Is mine.
Well, what's yours?
Because N equals M.
Well, that's for the first. That was for the first one, which were equal. You were supposed to say why the second one wasn't equal.
Well, because M isn't equal to M.
Yeah, there we go. You could say the second one. So M, if you would have N equals 2 times M, then that'd be
Because N equals M and N equals 2 times M.
Mm-hmm.
So what this means is, for the first set, you had 2 hydrochloric, you had 1 molarity of this, 1 molarity of that, same thing. They were both monoprotic. So if you had 2 grams of hydrochloric acid, you would need 2 grams of a base to neutralize it. If you have something like this, where you have monoprotic and diprotic, if you have 2 grams of this, well, you need, actually I'll do this one. If you had, either way, if you had 2 grams of this, this is diprotic, donate 2 hydrogens. So 2 grams of this would only neutralize the first hydrogen that this can give away. So you need another 2 to neutralize the second one. So that's why it's 2 times M. So you'd actually need 4 grams of this to neutralize all of that. If you have 2 grams of this, you need 4 grams of a monoprotic substance to neutralize it. That makes sense. That's why it's 2 times M. So number 12, why is the constant K, or what is the constant K with little w called? And what is its value? Sorry.
The ion product constant of water.
Yes. And what is its value?
1.00 times 10 to
Perfect. You need to remember that one. That is KAW. The ion product constant of water equals 1.00 times 10 to the negative, whoops, 14. That is the product constant of water. And if, remember, this equals the concentration of hydronium ions times the concentration of hydroxide ions. So if the concentration of hydronium and hydroxide ions were equal, they were neutral, what would they be? Or would they both have to be 13? What was that?
Are any of us supposed to answer?
Keep going, Sam.
71.00 times 10 to the negative 7.
Yes. Since KW equals concentration, so hydronium if these two are equal and neutral, pH is 7, both of these will be 1 times 0, 0 to the 10 to the negative 7th power. Because when you add those together, it comes up to this. If this one's more, if there's more hydronium atoms, it's going to be an acid. If there's more hydroxide, or if there's more molar mass of hydroxide, that's going to be basic. But let's go to number 13. What is pH?
The negative logarithm of hydronium ion molarity.
Logarithm.
Like how you can say that.
pH equals negative log
Mediocre.
that is pH. What is pOH? It's kind of like pH, but it's a little bit something that's different. What is it? Logan, do you know?
Is it the negative logarithm of hydroxide?
Yes. It's just the other. Yep. That's why it's OH. So, second part of that question was name 2 ways pH may be measured in the laboratory. Because you want to get those two. What are 2 things you got?
With a pH meter and with acid phase indicator.
Which one of those is electronic? pH meter. Any others? You've had universal indicators or pH paper or something. Okay. Megan, hopefully have all those answers. And no or hopefully no questions. Let's go to our problems. Problem number 2 was write the formulas for the conjugate bases of each of the following acids. So hopefully you understood this. Remember, conjugate acid. When a Bronsted-Lowry base.
You guys want ice cream?
Yes.
I wouldn't say no.
We'll go downstairs now.
Conjugate basis.
Let's go get some ice cream. Take a slight intermission.
Can you pause it? You can't pause it. Just let it go.
Megan, study everything that's on the board right now
You can see it.
while we're going.
I think I got it. Stop.
What was that?
I got my
These weird kids.
No, but
Be friends with me. Bam, I'm a cool kid.
solves that problem.
Sweet and salty things do not belong together. Unless it's chocolate covered pretzels, that's good. Sweet and salty things. Or salted caramel, I can do that.
We're back.
What?
It's a rain the first time probably in a year. Make a smoothie. Make a smoothie. I like sunny.
That's disgusting.
Make a smoothie. Not working very well. Man, so good ice cream.
Mm-hmm. It's really good ice cream.
What is that?
Really good ice
It's
cream.
really good ice cream. Like,
Oh,
I'll tell you what. I would just hate to be missing out on this.
It's
Wouldn't you, Megan?
excellent. Honestly.
Oh,
What is that? It makes me
Everything except for Izzy's.
That doesn't look one bit appetizing.
yeah, the smoothie. They're like,
No.
like the frosty things at Wendy's. It's basically
No.
that's what it's gonna be.
No.
So the strawberry.
alright.
Got wrong on so many levels.
All of
Yeah,
them.
you've never done this before. Me and Chris
No.
always do this chocolate syrup. Mix it all together so it's not a smoothie.
I think it makes it worse because it's strawberry.
Probably doesn't looks kind of.
Maybe look really weird. Like,
Oops.
It's so hard. And I have a plastic spoon that works very well.
Yeah, Megan, I hope you're enjoying being sick.
Okay. Okay, so we're supposed to write the conjugate acids, no bases. Conjugate bases. What are these
I'm
acids?
gonna drink it.
That's even worse.
No. I'm just seeing how far down you'll go.
I'm sure.
Okay.
Sure what?
See you.
Reagan, what do you have for the first one? So HClO4. What's the conjugate base?
ClO4.
ClO4. Okay. So
When I just took the H's off of everything.
Yes, did I?
that's what you're supposed to do. Because again, Bronsted-Lowry acid, when it donates a proton, it forms the conjugate base. So it donates
That's
this,
the wrong line.
means it's
Number
gone.
one.
But can't just leave like that and then
Why
it's the same.
It looks good as it is.
So what charges do? What charge does this have?
I wondered about that.
I did too. It's a negative.
What's that?
Negative.
So what charge is this gonna have when it leaves?
Negative.
Negative. So it's gonna be, and only lost one, so it's just gonna be ClO4 and then negative, just negative. ClO4 negative.
I actually put charges onto the others. So.
I did the
You
wrong
did?
one. I did number one.
Wisdom.
So number 2.
So Logan, what do you have for number 2? So H2O, this is conjugate base.
O2 negative.
What was that?
O2 negative.
O2 negative?
Mm-hmm.
Oh, 2 negative.
So like this.
No, like O2. Not 2.
Oh, gotcha. O2
Yeah, like that.
That is
Yeah.
not what I have.
No.
What do you guys have?
Oh, it's negative.
Okay, so it only donates 1 proton. That's why.
Yeah.
So all these, we just only donate. And when you do these, like when you say like what's the conjugate, ask what's the conjugate base for either one of these, you only just do 1, because that's what when a bronze Lowry acid donates a proton. So we just do 1, and it can do it again to lose another one, and again to lose another one, but just for like 1 step, only loses 1. So if we take one of these hydrogens away, then it just leaves us with O and an H, and then a negative because it lost a proton. That was a negative charge. And then what about, Izzy, what do you have for this one?
CN negative.
You have.
Is that good?
Perfect. You're talking about his ice cream?
Yeah.
Yeah, I don't know about that. And then, Greg, what do you have for the last one?
2, 4, 3 negative.
So PO4. And then 3 negative.
I wasn't sure about charge.
Mm.
What do you think? What do you have, Izzy?
That's what I have.
That's what you have. What do you think, Logan?
It's not what I have, but I'm probably wrong.
So,
I just have 2 negative.
okay, so again,
Mm-hmm.
if all of these gained a negative charge when they lost 1 hydrogen, so when they lost 1 hydrogen, it should gain 1 more negative charge, so it should be 3 negative.
It's also phosphate.
What was that?
That's phosphate.
It's right here. Or that right there. Yep, it's phosphate. And once it gets 3 hydrogens, it becomes acid. It's phosphoric acid. Okay, we're going to name the following compounds as acids. That's number 3. Alright, we're doing problem number 3 now.
I have written down new problems 2 to 4, but I only did problems 2 and 4.
Oh my. Do you guys do number 3?
Yeah, I did.
I
So
tried
Reagan
number
was
3.
Megan was the only naughty one.
I misunderstood.
Megan probably didn't do it, let's be honest.
Megan probably didn't do any of her homework. She's probably doing this before.
Try copying the answers.
I cannot believe you, Megan. Actually, I can believe that.
Do you feel the love, Megan?
You should know that we really miss you. You know.
Okay. So let's name these following compounds. Acids, remember the rules for binary acids.
I don't like this.
So acids that just have hydrogen and another element, like hydrochloric acid or something like that. When it's just HCl or something like that, you just do hydro, and then the other element's name, and then ic, and then acid. So it's HCl, it's hydrochloric acid. And if it's hydrofluoric acid, and so on. And then with the oxy acids, where it's hydrogen, oxygen, another element, they usually have those polyatomic ions. Yeah, so you should memorize that, or if you remember those. So it's H3PO4. This is phosphate, and if the polyatomic ion ends in 8, you change it to ick. If it ends in
I-
was ite, you change it to us. So this is phosphate, so phosphoric acid. I don't know, there's like, if you have nitrate, it's nitric acid. If you have sulfate, it's sulf, and so on. So let's name these other ones. So letter A, HiO3, and they tell you IO3 negative is iodine. So what would be the name of this acid, Logan?
Hydroiodic. Hydroiodic acid. Iodic? I don't know how to say it.
So why do you have hydro?
Because my hand wrote it down. I don't know.
Hand betrayed you.
Yeah, my hand betrayed me. Put it down.
So you've got to accept that. So the reason it doesn't have hydro is because it's not a binary. It's not a binary acid.
Almost none of these have hydro in front of them, do they?
Yeah.
Do
all the ones-
yours
all the
have
ones that-
hydro?
All the ones that just have hydrogen and another element, like B,
Soon.
and F.
So all the rest.
As I said, almost none of them have hydro in front of them.
No, not F.
As
Sorry.
I can tell
G.
from my own.
B and G have only hydrogen and another element. So those are the only ones that have hydrogen in front of them. All the others are just the names of the atomic ion. So that one would just be what? So without the hydro, it would just be
Iodic acid.
iodic acid. Yep. And then Izzy, what do you have for B?
I have hydroselenic acid.
Hydroselenic acid. Yes. Perfect.
Wait, say it again.
Hydroselenic acid. This
This is an N.
hydro
Strawberry syrup.
Accent is too much syrup.
hydroselene. For selene. Selenic acid. Hydroselenic acid. That's for binary. And then C, SiO4 for negative is silicate. So this would be oh, you haven't done this yet.
No, I'm trying to decide what it would be.
I was trying to.
Is
So-
it silicate acid? Or is it
I actually wondered about this one.
This is some not grammar, but English lesson for you too. So silicate, we change it to
Silicate.
8 to,
Silicate.
So it is silicate.
that's not how you say it,
Silicic.
silicic.
Oh, but I have. Is that actually like a word? Silicic.
I don't know, but that's how you say it.
probably not?
I makes
Use
this,
that hand
this
now.
I makes this C say. Whenever an I comes after a C, the C says it's.
Hey, man.
Nothing. Hangman.
Hangman.
Oh.
It's fun using these words in hangman.
That's what
Like hangman. So
Silicic. Yeah. Whenever an I comes after a C, the C says it's.
Every time it's I after C.
Whenever an E, an I, or a Y come after a C, the C says instead of K. So that's why this is silicic instead of silicic. So silicic acid. So when we have SiO4, which is silicate. You remember that one. D is HClO. B. Logan. HClO negative is hypochlorite. So
hypochlorous acid.
hypochlorous acid. Yep. E is wrong.
Formic acid.
Formic acid, yeah. So this says formate, so you change the 8 to egg, and we have formic acid. F, PO2, 3 negative, which is hypophosphate. So this would be
Hypophosphoric acid.
What was that?
Hypophosphoric
Oh,
acid.
it's hypophosphoric acid.
Oh, because it's phosphorus. Yeah.
So we're phosphorus and sulfur. We put in most of the rest of the name. So hypophosphoric acid, and then the last one, HI.
Hydro. Iodic acid.
That's right. Perfect. Hydroiodic acid.
At the beginning, I had hydroiodic, but G and A. Those are the same answer.
Oh, got you.
Clean iodic. Clean Iona.
Just remember phosphate turns to phosphoric, and that silicate turns into silicic. Remember those two. Did we
Sean, like,
Yes.
remember those two? So, like,
Really,
remember.
Remember.
That seems like, no, that seems kind of, C.
Anyways, moving on. Number 4.
And,
Look,
Right.
it tells you it right here.
yeah.
Does it not?
What?
Is that not what you were talking about?
Where?
H250. That thing?
Phosphorus.
It's double blue now.
Oh.
But there's two specifically. Do they say? Yeah, it's phosphorus and sulfur.
Ooh, that was not a good choice.
What?
I can't help you see it.
What's the colors?
The colors do.
Okay. Number
Gator.
question. Let's do problem number 4. Write net ionic equations for the following reactions. Okay. These are fun.
Are they?
Remember.
That was my big smile.
Don't overcomplicate these. Alright, I don't want
I
to.
did
I
it.
really didn't.
I don't want to. That's what I meant to say. I don't want to. Because all you have to do is split up things that are aqueous. Don't split up the things that are not aqueous.
I couldn't remember what that word was.
And split up. And if they are aqueous, make sure if they're ionic, like if they have a metal or something in them, they split them up. But if they're not, then make sure they're a strong acid or a strong base before we split them up. So first one, HCl plus NaOH yields NaCl plus H2O. Again, you need to memorize that table of strong acids and bases. You don't want to know this because you don't want to know, okay, HCl is a strong acid, NaOH is a strong base. So you're going to split those two up. Remember, they always put the cation first, the positive one first. So it's going to be H positive
Are all aqueous things supposed
plus Cl negative.
I have no idea.
Oh.
Plus,
Looking at me,
okay.
so you didn't want to say.
No, I just have no idea. I don't
So
know if it's-
HCl splits into H plus Cl negative plus NaOH, Na plus OH negative yields. What we got? NaCl.
You're gonna run out of fruit again, aren't
What was that?
you? Are you gonna run out of fruit?
Never. Is NaCl a strong base?
Do they have to be a strong base to be split up?
Yes.
Uh-oh.
It's not a strong base.
No? Okay. So we just leave it.
No.
Honestly.
Don't.
And then.
I'm not know what I'm doing, so.
Oh wait. Don't erase anything yet. You want the net, not just whatever. So I'm just looking for the last. Like the final.
Yeah, but I have everything written down.
Okay, so we have this right here so far. What doesn't change?
I originally crossed out Na and Cl.
Yeah.
Mhm.
You can still cross them out.
They didn't totally.
Oh, because those are still.
I mean,
those are still
these are
separated.
ions.
Okay. I gotcha.
So
Mhm.
that's why I said like you're just looking for your final answer, which is so our final answer would be H plus OH negative yields water. Make sure it's balanced. It is balanced. So. And you could split this up, and it wouldn't be wrong either, because again, you're looking for your final equation. You need to add the charges. Just when they have a formula like this, they always put the positive one first and the negative one second. So it's going to be H positive and Cl negative. And then if there's like a 2 here, it'll be H2 positive and Cl negative.
These are two where?
If they have it, because remember when you were making these H plus Cl, when you put them together, you switch the charges.
Mm-hmm.
When it's written here. So if there's a 2 after the Cl, that means the hydrogen has H2 plus. And if there's a 2 after the hydrogen, that means the Cl is going to have a Cl2 negative. Just remember that. Or that's remember what we've done before. So that's the first one. Second one should be
My fault. Didn't look at my hands after recess.
so BA.
Not my fault. Didn't look at my hands after recess.
You didn't lick my hands after recess.
Freaking salty.
BA plus HCl. Just remember that HCl turns into H plus and Cl negative. That'll get you a good ways. But H plus, and you can balance it after you're done too. So, but just make sure your final answer is balanced.
I'm a little confused on this one.
What is the final one? You split up BaCl2 is an ionic compound, and it's aqueous, so it means it's dissolvable. So it's soluble, which means we split it up. So Ba, remember, and you switch the charges.
Not every aqueous is split up, are they?
What was that?
Not every aqueous like solution or not every aqueous thing is split
Yeah,
up.
not it's just strong or weak acids and weak bases aren't split up.
Okay.
But this is an ionic compound because it has a metal or solid like a
So those are split up.
whatever this is. And it's BaCl2, so Ba has 2 plus, and then Cl negative. Plus H2.
She normally beats them out on the
Does she?
concrete. They normally beat them out in the concrete. Does she know she can't go in the concrete?
Does she? I don't think she does.
Maya, go.
The look on her face. Let's just beat them on the deck.
I think that's what we used to do.
I don't know, I used to do that. I used to like paint.
Yeah.
That might not be allowed to anymore.
I know.
Deck is crusty.
Dude, yeah.
We need to paint it again. Or we can do it.
Okay, so this is the same. This is the same.
Oh, it does have 2 positives.
Yeah.
Mm-hmm.
I put 2 positive on the
Yeah.
first one, and then they're pairing.
So Ba
Makes more
plus
sense.
H positive yields Ba2 plus H2. Is it balanced?
No,
What do we need to do?
you just put a 2. No?
I have a question.
Yes.
So this is 2HCl. Does that have anything to, does that do anything to the
I'm
HCl?
gonna balance it for you already. So I already put that there. No.
It doesn't do anything to it? Oh.
What did you have it doing?
Let's put it as 2H and 2Cl.
You can just balance it out and then you can figure it out and then balance it at the end. So there's 2 hydrogens over here, so there needs to be 2 hydrogens here. Charges don't matter. Don't worry about charges for balancing. This balancing is just number of atoms.
I just not this one right now.
I just wrote equals instead of units.
Okay, last one. Last one is okay. So you should split up first K2S. Just split that up. K positive and then S2 negative. Does that make sense? Like that. K positive, S2 negative.
Do you split up the next one? The AgN3.
Silver. Ag silver.
Yes.
Is it an ionic compound?
Silver.
Is it?
Yes.
Because that's not.
Oh, how do you tell?
If there's a metal and like a metal and a non-metal, it's usually an ionic compound. Remember, the other ones that aren't ionic are like covalent compounds, which is non-metal, non-metal, and then others are ionic because it's 2 ions that are transferring an electron. Flashback. So it should be K positive plus S2 negative
Yeah.
plus do it. No, I'm when you split. No, this isn't the net one. So K positive.
Did you write these down?
It's like a C hitter.
H positive.
Yeah, that's right. I don't know.
Oh boy, I might run out of room.
Shots.
What's in that big blue smudge?
It's really bad erasing.
Wait. Just put that. S and this.
Just did a
What?
What?
hob job.
Okay,
Did a hob job.
didn't run out of room.
It's like a
It's kind of like a mismatch. Like
Okay,
you
so-
just throw something together.
This is like your first split up right here.
Hot job.
So you don't split up this because it's a solid. So it's not dissolved. There's a little S set in the thing, so it didn't dissolve.
after the AG2S. What
Did
K,
you run out of
K
room?
positive
Did you-
plus NO3 negative.
Did you run out of room?
No,
No.
Good.
It's all in there. You ran out of room.
Yeah.
perfect. And then
There's like 1C or something.
so the K's are the same. The NO3s are the same. Okay, this stays together because it's a solid. It's not dissolved in water.
Here, it's
So it would be.
So it'd be S2 negative plus A plus 1 silver Ag positive yields. Oops, that's it.
Do you need the solid? Like the little S at the end? Do you need that?
Well then, if you do that,
You don't need it.
Show everybody the picture.
like, I won't count it wrong, but
We'll start with
It'd be nice.
it'd be nice. But also, because it'll help you also not
page 1, and she will sit down.
confuse them, hopefully.
Corner will come up, and
That's why those things are there for this, for one.
people
They're not there just
For
for
kicks and
anything.
giggles.
Yeah, for kicks and giggles. Let's do number 5. It's just a question. So, how many equivalent masses of NaOH are needed to completely neutralize 5 equivalent masses of a diprotic acid such as H2SO4?
10.
And
Is that
How'd you
right?
know that?
because it's double fine. I don't know.
2 times 5?
It's exactly what I was saying earlier. We had a monoproduct and a diproduct. So if you have 2 grams of whatever, you need double of the monoproduct to neutralize it. So here, and equivalent masses are equivalent. Same. Equivalent just means, number of equivalent mass is the mass needed to neutralize 1 mole of hydrogen or whatever. So if you need to neutralize 5 equivalent masses of a diprotic acid, how many equivalent of a monoproduct you need 10. Because you need double. Sweet. And then calculate the pH, number 6. Calculate the pH. We'll just do this quick. Whoa, where'd you get that, Logan?
I gave it to him, it's Megan's.
He found it.
Yeah, I found it.
I was gonna say. Oh wait, this is.
Now I know how
Well,
to
you
use
must
it.
remember to get one.
Not that know how to use it.
Okay, so
If you want to
let's
use-
find the pH of the letter A. So 0.10 molarity
You have to hit
Uh,
second, and then you can use
H
the yellow buttons.
and O.
If you want to
3.
use the white, you have to hit 30. And otherwise, it's just.
Okay, so did they give us the concentration of hydronium ions, or the concentration of hydroxide ions?
The second one's hydroxide, right?
What was that?
The second one hydroxide?
Yes. This first one is. So when this associates, what is it going to make? It's going to make hydronium or hydroxide ions. And HNO3.
There's a clear button on this thing.
Well, hydronium's going to.
You have to press it really hard.
Alan couldn't
Yeah.
find the enter button on yours.
I was trying to
It's
like.
right here.
I know it was.
The clear?
Yeah, I think it was enter button. Couldn't
Okay,
find
so
it.
the first one, letter A, they give us the concentration of hydronium atoms because it's when HNO3 splits up, it'll split up into H hydrogen ions and then like Na.
What do you do when it's 0.1?
So, this one you just have to put it into the log, into the pH formula.
Oh,
pH equals the negative log of concentration of hydronium. So, it should just be negative log of 0.10.
Is it 1?
that's all you need to do.
Was that?
1?
Yes. Oh, big time. Okay, I forgot about this.
Big time, guys.
Big time.
Big
Significant. Sig
Highlight.
clears.
It's like
Ah,
highlighter big time.
Well, just to remember, when you do pH, logs. When you do logs, it when you do the log, it gives you the number. When you do significant figures, you only do the numbers after the decimal point.
Because all the numbers to the right of the decimal.
So what that means is, if it gives you a number like 12.6789, whoa.
Whoa.
You don't round it. You don't worry about this over here. You just if you need to round it 2 significant figures, you do this right here. So 1, 2. You don't, because this tells you the pH. Like this is the base 10, so you don't worry about that. You don't change that. You just change. So you go 1, 2. So this would be 12.68.
You round to 2.
Yeah, if I was rounding to 2 significant figures,
Oh, okay.
this is what I would round it to.
Mm.
Because this is 2 significant figures right here. We don't count this as significant figures. This is just for logs, like logarithms. So if the logarithm was 13.14321, and I need to round it to 3 significant numbers, I wouldn't do 13.1. I would do 13. 13.143.
3.14159
Wait, what?
pi.
Oh, whoa. That was close to that.
Jeez.
Okay, so negative log of 0.10 would be equal to 1.00, or whatever the number gives you. It would be 1. And then, but we need 2 significant figures.
So,
1.00.
it'd be 1.00. The answer A would be 1.00.
They're right.
So Megan, if you're watching, only significant figures to the right of the decimal point. Those are the only ones that matter with logarithms. And then B, so they give you the molarity of hydroxide ions. So we need to change it to hydronium concentration because that's how we find pH. So remember, Kw, this equals the concentration of hydronium times the concentration of hydroxide. So we just need to flip that around a little bit if we want to find the hydronium concentration. So hydronium concentration is just the product constant, the ion product constant of water divided by concentration of hydroxide. Right? Does that make sense?
I have an answer.
If they give you the molarity of hydroxide of this, then you have to divide it by, or you have to divide it into 1.00 times 10 to the negative 14 to get the concentration of hydronium. So you can do this.
Yeah.
I don't have an answer yet, but
Oh.
actually, yeah, I do. But no. Yes.
But for hydronium,
Yeah.
I think
So
that's
now
where
you
you need
stick
to
it
get
in
log then.
yeah, you need to log it then.
Yeah.
Yeah.
I just was getting
I think that's what I had. I just did the log.
Mine is
I'm not gonna say that. I don't know.
a lot of 2's times 10 to the negative 13. How many 2's?
Okay.
You need two standard figures.
Well, did you press the log yet?
So it should be 2.2,
No. It won't work like that.
not pH.
I have to do 2.
What?
I'm not talking about pH. I'm just talking about the hydronium concentration.
Oh,
It should be 2.2 times 10 to the negative 13.
we don't need that. We can do it.
2.22.
What was that?
2.22.
Do we need to write that down though? That's not.
No, you don't need to.
So then,
Well, okay, it says, in the test it says show your work. So that means you're supposed to write what you do down. Otherwise I'll take some points off.
So, what if we do it all in our head?
So.
What if we do it all in our
I would
head?
be very impressed.
Then you should write down what you did in your
watch that
head.
too short about that. Math teachers.
No, it's important. When it says show your work, it means show your work. So like, write this down and write like pH, equals negative log. I know it's tiring, but
So what's the answer?
times 2.2 times 10 to the negative 13. That
Okay.
equals
7.
I get
7.
That's not what I have. I have very close to that. Actually, I would have that. Or 12.65. 7. 7.
Oh, you rounded it. 2.2. I just did this. You just do 2.22.
what's that?
You do 2.22.
I'm gonna use
That's
this
the
thing.
2.22. I just did
Is
2.2.
there no log on it?
Is it?
There
So
it
you
is.
have, do you have to
Where?
round it?
Somewhere.
You should. If you,
Just
because
log.
for this,
Yeah.
just put in this formula.
Wait, we
I
can
just
stick
I
it
didn't run anything, I
4.5
just kept
times.
going.
Why won't it let you do that?
I don't. Wait.
What are we rounding it
Wait,
to?
what do you do for this?
Well, it should be.
Let me see.
I
What?
was trying to
So
get like a
two.
10,
What did we
negative
start?
2.2.
So you start with 4.5, which is two
That's
sig figs.
I don't like this.
So you should round
You
it
can
to
use
two.
whatever. It's just an
That's the least amount.
More.
That one, I don't know how she uses that.
I want to see this.
It's really weird. It just does, like, you can't press log and
I
it
can't
does.
see anything. This man.
It's too busy.
Yeah. Just the log.
So it's 12.66. Yes?
Where's
Log. pH 12.66.
divided by 4, 5. This thing's the same thing as mine.
But where? Where do you find the EE? Oh.
How'd you get this number?
I don't know.
Mine is just.
Wait, so what do you do for this? You don't know to write.
1.00 times 10 to the 4.
4.0.
For
1.00 or times 10 negative 14 divided by, what was the 4.5 times,
second power.
yeah.
I feel like this is gonna
I
be
kind of want
pointless.
to see, try that one because I can see everything.
And then whatever answer you get for that is your concentration of hydronium.
Very nice. You can do all kinds of stuff.
Where's your EE?
There's no E.
What is it?
To do an exponent,
Yeah, I haven't figured it out then. I kind of
are you gonna do 10, like times
Yeah.
times 10?
Oh.
And then negative 3 or whatever.
You
Go
can't, you
back.
can't do negative after you're done.
Why would you want to do negative after you're done if you can just do it in the equation?
Oh, everything's so confusing.
So what you get?
Just wait.
What was that?
Please.
No.
So you
it's
have to
okay.
do that to get an exponent.
Do what?
That's annoying. Times 10, then you have
No.
to do
There's a
Yes.
just give me just a regular
So-
exponent.
Just run the two
it.
You can just
sig
do
figs
there's this.
because 4.5. So
And
2.2
there's,
times
like,
10
other
to
exponents.
should be negative 13.
Yeah.
2.2 times 10 to negative 13 to the power.
That's-
So that's your hydronium.
If you want,
That's
you can
this.
go back.
So now you can use your pH, negative log times
Directory button.
concentration. So you just negative, you just log that number, 2.2 times 10.
And you can fractions.
That's, you're not allowed to use that for math.
Why?
Because it's cheating.
Then
No, I did that
you need
whole
around
thing
2
in one
sig figs,
thing.
so you
Okay.
do 2 after the decimal point.
What's wrong about
66.
using the fraction button?
No, but like for consumer math, like if
Does
we
that make sense?
Yeah.
So you're gonna have to do something like this.
I never thought
Problem
about
just like that.
that.
This makes sense? You got it. This makes sense to all you guys? How to do a problem like this?
Yeah.
Come on, now to do
What do we
that.
label then? M
You don't label
or
it.
I mean
It's
pH?
pH, so you don't label it.
Okay.
It's just 12.66. Yeah, show your work and
Sure. That purplish blue mark that we done.
yeah, it's really nice. It came from this racer. So
You should be able to play like video games on the computer.
all right,
Play video games and yeah.
test. Everybody, take your test tomorrow.
No. Okay.
So
Some Call of Duty, you cockly.
I would buy that in a minute.
over your
I would never do
quizzes.
any work.
Go over both of the quizzes that you did. Yeah,
I
gather
was
some
going
stuff.
to.
That'll be a good help to you.
No.
And then just
That's so.
make sure that you go over the bold words
Like,
in your.
I just figured like you can just do problems like
That's
that.
cheating.
that's what I said.
That's not cheating.
Okay, makes sense. Look at study your quizzes. Study the bold words.
Is there a
And
essay question?
yes,
You said you already said you won't tell us what it is.
But I
Okay.
forget.
essay questions easy. So they're easy enough. I
Even if I
Push
ace
straw.
this test, we've had 2 quizzes, right?
yes.
Averaging it up, I get a 73.
Your quizzes are only like a third of your test score or something like that.
Please say they are.
Yeah, they are.
Yeah, I think it's around.
They're not the
So-
whole. They're not. I don't think they're half.
What'd you get on your quizzes?
Not good. Not terribly wrong.
So
I forget what
you said
I know what I
mentioned
got on
something
one
one time
I did.
about the essay question.
I did.
Yeah.
I did.
Shoot, I have money for your mom. I should have it in my hand.
Thank you.
I'll be here.
You'll be there.
What were you saying?
I feel like you told us one thing
Okay,
about
you guys
essay
are dismissed.
I don't think he did.
You are?
I really think
I don't think he did.
He did.
popcorn. It has to be
About what?
popcorn.
That was good.
Oh, do you guys know what equivalence point means
Equivalence.
in titration? Like
Oh,
when you
it's-
titrate and it comes to the equivalence
It's the
point.
point
You know what
that
that means?
reaches where like the acidity is neutralized because you added enough base or something like that. Or you added
Equivalence point
enough-
means you add the same amount of acid as what there's base in it.
You said it had. Oh.
Or whatever. It's
that
like
where
the same.
acid
It's where the
Okay.
it's where the acid, like what you said, like the acids and the bases, like they come to a point where they neutralize. So as long as you know that, you figure out.
Oh.
So that's what the essay question is about.
Titration.
Not exactly. I'm just saying if you know what that word means, equivalence point. If you read that, and you know what that means, then you'll be able to figure out what the
Equals
answer
a
is.
mole of acid base.
Yeah, you'll be fine. With your stickers. I believe in you guys.
I just probably.
I did. Done?
Might be
Yeah.
Place Faith.
What was that?